Good morning. My name is Salvatore Maduzzi from the University of Udine, and I will describe my project, which is related to the implementation of a GIS to do an analysis of the strategical planning of elections campaign. I am responsible of the Geomatic Lab of the University of Udine, where we do implement GIS, WebGIS, geomarketing, applied to land use changes, cultural heritage, fleet management, territorial marketing, presence and movements of people derived from cell phone data, mainly applied to, let's say, tourist and social sentiment analysis. In this project, we have applied the GIS technology to analyze all the elections pools data mixed together with socioeconomic and geographic data in order to give information to the parties in order them to be able to understand which areas of the city of Udine and which type of voters they would have better get in contact in order to let them vote for their party. The answer we and the parties were looking for, in particular regarding the application of the GIS, is if the GIS can be used to find which socioeconomic and demographic factors are spatially affecting the political party and the results of the elections for the political party, and once defined the clusters of the voters, if GIS can be used by the parties in contacting the right clusters to increase the number of votes. The area and the election that we have been analyzing are related to the city of Udine, which is in the region Friuli Venezia Giulia, which is the northeastern region of Italy. And the data, as you will see later, are at a census sections level. The city of Udine is a city with approximately 100,000 people, inhabitants, and it's divided in 900 census sections. And for each census section, the Italian Statistical Office is providing more than 100 in socio-demographic indicators. Data and information that we have been using are let's say, from the GIS and geographic point of view, the regions of Italy, the municipality of Friuli Venezia Giulia, the census section of Friuli Venezia Giulia, the road network of Friuli Venezia Giulia, the house number of Friuli Venezia Giulia, the polling station of the city of Udine, the voters, so the database of the voters of the city of Udine, and a database that we have related to the income and expenses of the inhabitants of each census sections. Then we had the Excel file with all the 2011 census of Friuli Venezia Giulia at a census section level. And then we had the results per polling station of the election in 2013. The other documents we have been studying and discussing with a group of people that were working for the campaign of Obama with Jim Messina. And we had a document explaining how to use the income expenses data that we have been using in this project. This flowchart describes the methodology we have used in the project. So data flattening, all these different data coming from different sources and of different formats have been put together. On all this data, it has been applied a statistical and spatial analysis. Statistical analysis using SPSS and spatial analysis using GIS. We have been using different GIS, ArcGIS, MapInfo and QGIS. And then we have been mapping the results and deriving the conclusion that you will see later. In the database of the voters, these are the factors and indicators that we have taken in consideration. So as you can see, the age of the voters, the gender, the marital status, the education, the house ownership, if they are Italian or foreigners, where they come from, the employment, and if they are coming from other municipalities or they are moving in or out the city. For the income expenses, the factors were the total income of the family, the expenses on food, the non-food expenses, and the bank savings. As I told you, these data are at a census section level. And remember that in Italy, a census section is approximately is an area which approximately contains 100 inhabitants. And from the 2013 elections, the data for each poll station were the number of voters, the null votes, the premier votes, and the number of votes for each political party. Here in this map, you can see the first representation of all the data after the flattening activity. So the voters, the census sections, the polling station, and in this slide you can also see the results of the election. We had a coalition of 4 parties, a coalition of 6 parties, and some other party that, let's say, had less votes. We applied to all this information using SPSS software. We have done a statistical analysis divided in 2 parts. The first is a bivariate correlation to understand which of these factors were related, and the OLS, the ordinary least square tool, in order to understand how this data, how these factors were connecting one to each other. In the next 2 slides, we will focus on one of the parties, the coalition of 4 parties, and we will, as you can see here in green, are the indicators with high value of correlation coefficient with the number of votes received by the party. So it means that there is a high correlation between the high number of votes and the high number of people between 0 and 19 or more than 74 years, the people with secondary diploma, the people employed 15 and above, and so on. We then, working with this data, we realized that in order to increase the model performance, one of the activity that should have been done was the division between male and female. Dividing the male and female database, the correlation between the factors and the votes were really more precise. And so this is a sample on which are the factors of correlation between male on the left and female on the right with the coalition of the four parties. We then start mapping the results, and here are a couple of samples on some maps. For example, the number of votes on the left, the number of votes received by the coalition of four parties in the census section, shown, as you can see, with graduated symbol. The more the circle is bigger, and then bigger is the number of votes. On the left, the coalition of four parties, and on the right, the coalition of six parties. These are other two samples of results mapping. In this image, the coalition of four parties is overlaid, the votes of coalition of four parties, so the census sections, is overlaid with the number of people owning their house. So the higher is the percentage of families with home ownership, and the higher is the percentage of votes for the coalition of four parties. On the right, always coalition of four parties, the votes are overlaid with the male graduates. So here we can see that the lower is the percentage of male graduates, and the higher is the number of votes. So as you can see, once the spatial analysis and statistical analysis has been done, you can extract lots of information from this geodatabase, and you can understand which factors are really influencing the votes. And so it's possible for a party to understand in which area of the city and is living which cluster of people. And so if you need to convince someone, you know who are the cluster that's easier to convince to change vote or to go to vote because they didn't vote that time. We will now do, let's say, a second step on this project, and the future scope of the project will be finding which other socioeconomic data are affecting the votes and are in some way dependent variables with the number of votes. And then we, in this project, we focus on the pool on the election 2013, and we are now acquiring all the historical data of all the previous election in order to make and to improve the precision of the model. I thank you very much, and I'm here for any doubt or answer.